Problem 1.9 is a conceptual question. It asks us whether something is true or false. So part A, for all quantum mechanical states, the probability density is always equal to this value. Is that true or false? This is very clearly false because this value can only be equal to this for stationary states. And if we don't have a stationary state, we can never write the probability density of a state function that depends both on the x and the time as only the probability density of a function that is x dependent and totally independent of time. So we can never do that. This is true only for stationary states, and so it's not true for all quantum mechanical states. So the answer here is false. Now moving on to part B. For all quantum mechanical states, the state function or the wave function is the product of a function of x and a function of t. I'm going to give the answer. The statement is also very clearly false. And that's because you can only separate this function, or this function can only be separable into a time-dependent and an x-dependent function only in certain cases. So this function is not always separable. If, let's say, you can separate it if this has a function of some at times bx and some constant. In this case, you can very clearly separate it out into two. However, if you have something like some constant times e to the negative a t times x or something, then there's no way you can separate this function into two different functions that depend only on time, only on x. So the key point to note is that this particular function is not always separable. So here, for simplicity, we've assumed that this function could be separable, and we derived certain equations, and we also ended up with a time-independent Schrodinger equation, but that is not necessarily the case for a lot of real-life phenomena. We cannot really separate out the time and the spatial parts of the state function or the wave function. So the answer for both parts A and B is false.